This is the Manis Academy of Education. My dear student, we will now learn chapter number 7 of standard 12th for same AC voltage applied to an inductor. From the figure we see that here applied voltage, here inductor. We know that inductor is consist of some metal, so there is a presence of resistance also. But here we are going to consider that the resistance is very low with respect to this circuit. So see, usually inductor have an appreciable resistance in their windings, but we shall assume that this inductor has a negligible resistance, and thus the current is purely inductive AC circuit. Let the voltage across the source be V equal to Vm sin omega t, and using the Kirchhoff rule, total sum of applied AC voltage is equal to 0 with respect to time t, and there is no resistance in the circuit. Now V minus L di by dt equal to 0, where the second term minus L di by dt is the self-induced Faraday EMF in the inductor, and L is the self-inductance of the inductor. The negative sign follow from the Lenz's law, and so we can write here di by dt equal to V by L, and we know that V equal to Vm sin omega t, so put it here Vm sin omega t divided by L. So from this equation we can get that the equation for it, the current as a function of time t, must be such that its slope di by dt is sinusoidally varying quantity and with the same phase as the source voltage and amplitude given by Vm by L. To obtain the current, we integrate di by dt with respect to time t. So integration sign on both the side LHS and RHS. So integration di by dt into dt and is equal to Vm by L constant term, and then integration sin omega t dt. By the mathematical rules, we integrate them and we will get that current, total current I is equal to minus Vm by omega L cos omega t plus constant. The integration constant has the dimension of current and is time independent, since the source has an EMF which oscillate symmetrically about 0, and the current is sustained also oscillate symmetrically about 0, so that no constant or a time independent component of the current exists. Therefore the integration constant is 0. Now minus cos omega t is equal to what? Sin omega t minus pi by 2. Here sign is changed. In general, by mathematical rules, sin pi by 2 minus omega t or a plus omega t. So we can get I equal to Im sin omega t minus pi by 2. And now Im equal to Vm by omega L is the amplitude of the current, and the quantity omega L is the analogous to the resistance and is called inductive resistance denoted by XL. So XL equal to omega L, and so we can write here Im equal to Vm by XL. The dimension of the inductive reactance is the same as that of resistance, and its unit is also ohm. The inductive reactance limits the current in purely inductive circuit in the same way as the resistance limit the current in purely resistive circuit. The inductive reactance is directly proportional to the inductance and the frequency of the current. As comparison, the source voltage and the current in inductor shows that the current lags the voltage by pi by 2. Current lags by pi by 2 with respect to voltage. 1/4 1/4 cycle. So figure 7.6 shows the voltage and the current phasors. In the present case, at instant t1, the current phasor I is pi by 2 behind. The current phasor I is pi by 2 behind the voltage phasor V. When rotated with frequency omega counterclockwise, they generate the voltage and the current give respectively as in the figure. Here we can see that omega t 1 voltage and I. So there is a difference of pi by 2. This is the fourth quadrant. This is the first quadrant. The current lag behind voltage by pi by 2. So here we can write voltage equal to Vm sin omega t 1, and here current Im sin omega t1 minus pi by 2. And from wave function also we can see that voltage is lag forward and current is lag behind by pi by 2. So we see that the current reaches its maximum value later than the voltage by 1/4 of the period. It means t by 4 is equal to pi by 2 divided by omega. And you have seen that an inductor has reactance that limits current similarly to resistance in a DC circuit, and does it also consume power like a resistance. Let us try to find out. The instantaneous power supplied to the inductor is equal to PL. L for inductor, PL equal to IV, I equal to Im sin omega t minus pi by 2, it is lag behind, into Vm sin omega t. Now minus Im Vm cos omega t sin omega t. So we can get minus Im Vm by 2 sin 2 omega t. Here we are multiplying with 2 and dividing by 2. So nothing difference in this equation and also in this equation. But the average power over a complete cycle is equal to PL is equal to minus Im Vm by 2 sin 2 omega t. And then we get is equal to minus Im Vm by 2 sin 2 omega t equal to 0. Since the average of sin 2 omega t over a complete cycle is 0, and thus the average power supplied to an inductor over a one complete cycle is 0. It means what? Fully charged inductor will transfer into electric current again, and it will be 0. And these things we will learn in AC generator also.